waves. Very rare to see it. So the cardiac cycle already explained by Mr. Eric. So why is it important? Because if I saw an abnormality in the B wave, okay, I will suspect abnormality in the atrium. If I have abnormality in the QRS, abnormality in the ventricle. T wave also ventricle. ST segment, ventricle ischemia, okay? What about PR interval? Represent what? Represent the AV node. The AV node. If I have problem with the APR interval, maybe problem with the AV node, okay? So you see this, everything is normal except the B wave. So something in the atrium. Everything is normal except the PR interval. So something in the AV node. So you can isolate the problem. Okay, so this is the conduction system and how it affects my ECG. So from SA node until the beginning of the Purkinje bundle of hairs, all of this is in the atrium. Okay, so the AV nodes in the middle. If you have delay conduction in the AV node, it will make the BR interval long from beginning of the wave until beginning of the QRS. It will be more long. Okay. So now we will approach the ECG in a systematic way. So first you see the rhythm, is it regular? Then the rate, then you will see the P wave, start the P wave, assess the P wave, assess the QRS complexes, the PR interval, the ST segment. Let's go in detail now. So you need, before you have diagnosis, this is AF, this is ventricular tachycardia, this is PVCs. Isolate the abnormalities first. You have a checklist. You need to make a checklist for your ECG, especially the one printed. Just study, okay? These steps. First, what we need to learn from the ECG. First of all, if the patient, alhamdulillah, have heart rate, is not in arrest. So this heart rate produced by which control? Okay, this is the pacemaker. Then the next thing, how this control will spread in the heart? Is it spread normally, or there is some blockage in the way, some delay, some disease make the electricity go slower? Okay. So sometimes you have two pacemakers. So you identify the pacemaker. You find another pacemaker. We will learn how the pacemaker initiate the B wave or may not initiate the B wave. So if initiated by the B wave, so probably sinus. But if you have two B waves, maybe you have something else with the sinus node that's producing the pacemaker. Okay. But if you have no B wave, means you have some other source able to contract the ventricle without the atrium contraction. So this is ventricular pacemaker, okay? Or you have the B wave in a different place. So how to know the rhythm is regular? Huh? Yeah, regular means it's coming in fixed time, every 1 second, every 2 seconds. So how to measure the time? By the paper. Again, every 1 second, 5 large square. So here, I will measure the distance between the waves and see, here is not equal. So this is irregular. Here, I will measure the distance between these waves. I find it equal. So the time is equal. So this is irregular, so when we say something regular means in the fixed times, okay? What about this one? Irregular. But you see, there is a fixed pattern here. This fixed pattern. Two long space, two and long space, two long space. And this long space is equal. Okay? It seems to be irregular, but with regularity. Regular, irregular. Okay? And this also irregular. You can identify it visually, but sometimes irregularity starts gradually. Irregularity will start gradually. Maybe the irregularity is slowly appearing in your ECG and it's very fine. you need to really measure it and count, and you will find maybe one small square is different, or two small squares. Until you see it by your eyes, too late. Yani it's already started long time before. So you can identify regularity by measuring. Okay? Then identify the rate. I told you how many large square in 60 seconds? 300. How many small square in 60 seconds? 1,500. Okay? How about I will say how much one beat takes? How can I know if this beat takes how many large square? I will measure the beginning of one beat to the beginning of the second beat, and then let's say 5 large squares. So this beat takes 1 second. If it is 3 small squares, so it's less than 1 second. So how can I know? Measure this distance and divide the 300 on this number. So let's say here 1, 2, 3, 4, 5, and 6 large square between the RR interval. So you have divide 300 by 6. How much? 50. So it is knowing the heart. It's good if you have regular. So you measure 1 RR. But if it is irregular, like what you will do? If it's irregular or regular, you can see this paper takes 6 seconds. How many waves in the 6 seconds, and multiply by 10. Multiply by 10 because there is 60 seconds in the minute. Okay? Then you see the P waves. So P waves must be present, must be before the QRS, and you have one B wave, and the B wave has to be positive deflection like QRS or negative deflection like QRS. The QRS has to be positive, B wave positive. Negative, negative, okay? Here, for example, you see sometimes there is B wave and other wave, no, absent B wave, okay? So here is absent. Here, the B wave does not come before QRS, it comes before and after and even on top of the QRS. Sometimes comes on top of the QRS, okay? And here, also we can see absent B waves. Okay, this one is T wave, not B wave. Here you can see present, and after that it is before, same direction with the QRS, and only one B wave before each QRS. Then you will see the PR interval. So beginning of the B wave until beginning of the QRS. It has to be less than 5 small square. Okay? So here I see the B wave. When I zoom in, I see 1, 2, and another 5, so 7. I said only 5 small square is the normal for PR interval. More than 5, prolonged PR interval. Prolonged PR interval. Later on you will learn about heart block. You can diagnose from PR interval. Okay? Here we can measure it. It is 5 small square. So it is normal. 5, 4, 3 is normal. Okay? And the PR interval, you measure it you see it has to be same for all the waves. Maybe you measure it one wave, it is 5 small square. The other one is 7. The other one is 8. So it is progressively increasing. Okay? It has to be same and equal on all waves. Then you will see the QRS complex. The QRS complex has to be also uniform. Okay? It has to be uniform. It has to be narrow, less than 3 small squares. More than 3 small squares, it will be wide. How to measure it? Beginning of the QRS and end of the QRS. Beginning of the Q wave, end of the S wave. Okay? From the start of the negative deflection of the Q wave till the J point. This distance is the QRS time, and it should be less than 3 small squares. Okay? So here is a wide QRS. If you measure it, it will be 4 or 5 small square. This is wide QRS. Okay, one of the ventricular arrhythmias. It will be here. How many small squares? You cannot measure it. There is no QRS. Okay, this is ventricular fibrillation. Okay, here is white QRS. Then you see the ST segment. So the ST segment we will measure from which point? J point. The J point is here. The end of the S wave, then start of the ST segment. This is, so how, 1, 2, how many small squares? 2. How many millivolt? Huh? 2 small square. 0.2 millivolt. So the ST segment elevation is 0.2. Okay? The other one, what about here? How many large small square? I have 1, 2, 3, 4, 5, 6, and 7. 0.7. So how did I measure it? I measured the start of the deflection, the end of the ST wave deflection, then start of the ST segment. There is an angle. This angle, this is the J point. From where? From the isoelectric line. How can I know the isoelectric line? Even the ST segment elevated. See the PR interval. It will be always in the isoelectric line. Okay? Even if your paper is not. Then you will see the something called QT interval. QT interval, beginning of the Q wave, end of the T wave. It has to be less than 0.44 seconds. If it taken longer, means prolonged QT interval, and it's very common to have it with some medications, some antibiotics even cause QT, prolonged QT interval.
Thank you, Mr. Ahmed. Okay, take a break at 10, please, and be here at 10. Thank you. Thank you, sir.